Using binomial theorem, we are going to learn to write the expansion of a plus b whole raised to n, where n can be any integer or it can take any rational value. But in 11th standard, we will learn binomial theorem only for positive integers. A plus b whole raised to 0 is 1. A plus b whole raised to 1 is a plus b. And a plus b the whole square. The expansion is a square plus 2ab and plus b square. Then a plus b the whole cube. This expansion we know, which is a cube plus 3a square b plus 3ab square plus b cube. Similarly, we can write the expansion for a plus b whole power 4, which is a power 4 plus 4a cube b plus 6a square b square plus 4ab cube and plus b power 4. If you see, for index 0, that is for power 0, the expansion has only one term. And for power 1, the expansion has two terms. If the index is 2, it has 3 terms. If the index is 3, it has 4 terms. For the index 4, we have 5 terms. We have one more term than the index. So in general, a plus b whole raised to n will have n plus 1 terms in the expansion. And see the powers of a. The power of a is going on decreasing. Here it is power 4, then cube, then square, then power 1 and a power 0. Whereas if you see the power of b, here power of b is 0, here it is 1, here it is 2 b square term, here b cube, here b power 4. So the power of b term is going on increasing. And if you see the total power, the degree of this term is 4. The degree of this term, a cube into b, 3 plus 1, 4. And a square b square, 4. And a b cube degree is 4. And here also the degree is 4. So degree will be the same as the index, as the power of that binomial expansion. We are using two terms, that's why it is binomial. Now see the coefficients of these terms. So initially for the index 0, it is 1. For the index 1, the coefficients are 1 and 1. And for the index 2, the coefficients are 1, 2, 1. See the coefficient of the first term 1. Here it is 2 and 1. Then for the index 3, see the coefficients. We have 1, 3, 3 and 1. And for the index 4, the coefficients are 1, 4, 6, 4 and 1. We can write the coefficients for the index 5. See, they follow a pattern. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1, 4. The first and the last terms will have the coefficients 1 and 1. The second term coefficient will be 1 plus 4, which is 5. Then the next coefficient will be 4 plus 6, which is 10. And then 6 plus 4, 10. 4 plus 1, 5. And the last coefficient is 1. And this is called Pascal's triangle. If we have to write the expansion for a plus b whole power 25, writing all rows to find the coefficients of all the terms is going to be difficult. So we are going to use combination formulae. This coefficient is NC0. Here n is 0, 0C0 which is 1. And this coefficient is 1C0. And this is 1C1. And for the index 2, the first coefficient is 2C0. The second coefficient is 2C1. And this is 2C2. For the index 3, the coefficients are 3C0, 3C1, 3C2 and 3C3. And for the index 4, the coefficients are 4C0, 4C1, 4C2, 4C3 and 4C4, etc. We know the formula of NCR. NCR is equal to n factorial divided by r factorial times n minus r factorial. Now let us write the expansion for a plus b whole raised to 6. So the first coefficient will be 6c0 and a power 6. The second coefficient is 6c1. So we call them as binomial coefficients. 6c0, 6c1, 6c2, etc. up to 66. So keep decreasing the power of a term. So it becomes a power 5 and keep increasing the power of b term. The next term will be 6c2 a raised to 4b square and then 6c3 a cube and b cube plus 6c4 reduce the power of a square and increase the power of b. 6c5 reduce the power of a, it becomes a raised to 1 which is a and b raised to 5. And the last term is 6c6 a power 0 which is 1 times b power 6. This is the expansion of a plus b whole power 6. Now we can easily write the expansion, binomial expansion for any index which is a positive integer. Now let us write the binomial expansion for the positive integer n. A plus b whole raised to n is, the binomial coefficients will be nc0, nc1, nc2, etc. up to ncn. nc0 a raised to n. The next coefficient is nc1. Reduce the power of a and increase the power of b. nc2 a raised to n minus 2 b square. The next term nc3 a raised to n minus 3 b cube plus etc. The last term will be ncn a power 0 which is 1 and b raised to n. And this can be proved easily by the principle of mathematical induction method. And this expansion can be written using sigma. Sigma k is equal to 0 to n of nck a raised to n minus k and b raised to k. In this expansion, we have n plus 1 terms because it starts with 0 to n. So n plus 1 terms are there. Degree of each term in this expansion will be n. Let us write the binomial expansion of a minus b whole raised to n. This can be written as a plus minus b whole raised to n. First term will be nc0 a raised to n. Second term is nc1 a raised to n minus 1 minus b whole power 1. Then third term nc2 a raised to n minus 2 minus b raised to 2 plus nc3 a raised to n minus 3 minus b raised to 3, etc. The last term is ncn a raised to 0 will be 1 and minus b raised to n. nc0 a raised to n. The second term becomes negative because we have minus b. Therefore, the second term is minus nc1 a raised to n minus 1 b.
third term
will be positive because minus b the whole square is plus
b square.
The next term will become negative because we have minus b the whole cube, which is minus b cube. The next term is minus nc3 a raised to n minus 3 b cube plus etc. We don't know whether the nth term is positive or negative. It depends upon the value of n. If n is an even number, it will become a positive term. If n is an odd number, it will become a negative term. Therefore, we will write the sign as minus 1 whole raised to n, ncn b raised to n. Therefore, the expansion of a minus b whole raised to n has alternate positive and negative terms. Let us write the expansion of 1 plus x whole raised to n, which is nc0. 1 raised to any number is 1, plus nc1 x plus nc2 x square plus etc. The last term will be ncn x raised to n. The expansion of 1 minus x whole raised to n will have alternate positive and negative signs. nc0 minus nc1x. Because x is negative, minus x, that minus sign I have written as minus nc1x. The next term will be positive. Next term becomes negative, etc. The last term's sign depends upon the value of n. So minus 1 whole raised to n, ncn x raised to n. Exercise 8.1. First question. Expand each of the expressions in exercises 1 to 5. 1 minus 2x whole raised to 5. We know that the binomial coefficients are 5c0, 5c1, etc. up to 5c5. So 5c0, 1 power 5 is 1. And alternate positive and negative signs. So minus 5c1, 2x plus 5c2, 2x the whole square minus 5c3, 2x cube. Actually it is minus 2x the whole cube. That minus sign is written here. So don't write minus here as well as minus 2x the whole cube here. Plus 5c4, 2x raised to 4 and minus 5c5, 2x raised to 5. Let us simplify this expansion. 5c0 is 1. nc0 and ncn are equal and they are 1 minus 5c1 and 5c4 will be same 5. In general, nc1 and ncn minus 1 are equal and they are n. 5 into 2x plus 5c2. 5c2 is 5 factorial divided by 2 factorial into 3 factorial. If we cancel 3 factorial, we get 4 times 5 divided by 2, which is 10. And this will be equal to 5c3. 5c2 and 5c3 are equal because NCR is equal to NCN minus R. 5c2 answer is 10 into 2x the whole square will become 4x square minus 5c3 is again 10, 8x cube plus 5c4 is 5, 16x power 4 minus 5c5 is 1, 2 power 5 is 32, 32x raised to 5. The answer is 1 minus 10x plus 40x square minus 80x cube plus 5 16s are 80, x raised to 4 and minus 32 x raised to 5. Second question. expand 2 over x minus x over 2 whole raised to 5. Let us write the expansion. 5c0 2 over x whole power 5 minus 5c1 2 over x whole raised to 4 and x over 2. Next term will be positive. 5c2 2 over x the whole cube times x over 2 the whole square. Next minus 5c3 2 over x the whole square x over 2 the whole cube. Next term is positive. 5c4 2 over x times x over 2 power 4. The last term is minus 5c5 x over 2 whole raised to 5. Let us simplify. 5c0 is 1. 2 raised to 5 is 32 over x raised to 5. Minus 5c1 is 5. 16 over x raised to 4 and x over 2. Plus 5c2 is 10. 8 over x cubed times x square over 4. Minus 5c3 is also 10 times 4 over x square and x cube over 2 cube is 8. Plus 5c4 is 5. 2 divided by x times x raised to 4 divided by 16. Minus 5c5 is 1. X raised to 5 over 2 raised to 5 is 32. Therefore, the answer is 32 divided by x raised to 5 minus, let us simplify this, we get 40 over x cube plus 20 over x minus 5x and plus 5 divided by 8x cube, and last term is minus x raised to 5 divided by 32. Question number 3. 2x minus 3 whole raised to 6. The first binomial coefficient is 6c0. 2x raised to 6. Alternate positive and negative signs. Minus 6c1, 2x raised to 5 and into 3. The next term is positive. 6c2, 2x raised to 4. Decrease the power of 2x term and increase the power of 3. 3 square. Minus 6c3, 2x raised to 3 and 3 raised to 3. Plus 6c4, 2x raised to 2 and 3 raised to 4. Minus 6c5, 2x times 3 raised to 5, and last term is plus 6c6, 3 raised to 6. Let us simplify the terms. 6c0 is 1. 2 raised to 6 is 64. And x raised to 6 minus 6c1 is 6. 2 raised to 5 is 32. X raised to 5 times 3. The next term, 6c2. The formula is 6 factorial divided by 2 factorial times 4 factorial. Cancel 4 factorial. 5 times 6 divided by 2, which is 15. 15, 2 raised to 4. 2 raised to 4 is 16. X raised to 4 and 9. Minus 6c3 is 6 factorial over 3 factorial times 3 factorial. Cancel 3 factorial. 4, 5, 6 divided by 2 into 3, which is 20. 2 cube is 8. x cube. 3 cube is 27 plus 6c4 and 6c2 are equal, which is 15. 2 square, x square, 3 raised to 4 is 81. And then minus 6c5 is 6 times 2x. 3 raised to 5 is 243 plus 6c6 is 1 and 3 raised to 6 is 729. Let us simplify this expansion. First term is 64x raised to 6 minus 192 times 3. 576 x raised to 5 plus the next term is 16 times 9, 144 times 15, 2160 x raised to 4. The next term is negative 27 times 8, 216 and times 20. So it is 4320 times x cube plus 15 fours are 60. So 81 times 60. 4860 x squared minus 243 times 12. 2916x. And the last term is 729. Question 4. Let us write the expansion of x over 3 plus 1 over x whole raised to 5. So it will have 6 terms. First term is 5c0 x over 3 whole raised to 5. Then plus 5c1 x over 3 whole raised to 4 times 1 over x plus 5c2 x over 3 whole raised to 3 times 1 over x square plus 5c3 x over 3 the whole square 1 over x the whole cube plus 5c4 x over 3 times 1 over x the whole power 4. And the last term is 5c5 1 over x whole raised to 5. 5c0 is 1. We get x raised to 5 divided by 3 raised to 5 is 243. If c5 is 1, x raised to 4 over 81 times 1 over x plus 5c2 is 10. X cube over 27 times 1 over x square plus 5c3 is also 10. X square divided by 9 times 1 over x cube. Then 5c4 is 5 times x over 3 and 1 over x power 4 plus 5c5 is 1. 1 divided by x raised to 5. First term is x raised to 5 over 243 and the second term is 5 over 81 times x cube plus 10 over 27 times x plus 10 over 9 x in the denominator plus 5 divided by 3x cube and plus 1 divided by x raised to 5. Question number 5. Binomial expansion of x plus 1 by x whole raised to 6. 6c0 x raised to 6 plus 6c1 x raised to 5 times 1 over x plus 6c2 x raised to 4 times 1 over x the whole square plus 6c3 x raised to 3 times 1 over x the whole cube plus 6c4 x raised to 2 1 over x raised to 4 plus 6c5 x and 1 over x raised to 5 plus 6c6 1 over x whole raised to 6. 6c0 is 1. So the first term is x raised to 6 plus 6c1 is 6 and cancel x, so it becomes x raised to 4. 6c2 is 6 factorial by 2 factorial times 4 factorial. Cancel 4 factorial, 5 times 6 by 2, which is 15. 15 x square plus 6c3 already we calculated in the previous question. It was 20. X cube and x cube will get cancelled. So this is independent of x term. There is no x term in this. 6c4 and 6c2 are same, which is 15 divided by x square plus 6c5 is 6 divided by x raised to 4 plus 6c6 is 1 divided by x raised to 6. Question number 6. Using binomial theorem, evaluate each of the following. 96 the whole cube. We can write 96 as 100 minus 4 the whole cube.
Powers of 100 are easy to calculate.
The expansion is 3c0, 100 cube, alternate positive and negative signs. 3c1, 100 square times 4 plus 3c2, 100 times 4 square minus 3c3, 4 cube. 3c0 is 1. 100 cube minus 3c1 is 3. 3 4s are 12. So into 100 square will give you 120000 and then plus 3c2 is 3. 4 square is 16. 48. 48 into 100. 4800 minus 4 cube is 16 times 4, 64. Now add the positive numbers together and add the negative values. Therefore, the answer is, subtract and write, 6, 3, 7, 4, 8 and 8. Question number 7. Similarly, we can write 102 whole raised to 5 as 100 plus 2. Because powers of 100 are easy to calculate. Let us write the expansion. 5c0 100 raised to 5 plus 5c1 100 raised to 4 times 2 plus 5c2 100 raised to 3 times 2 square plus 5c3 100 square and 2 cube plus 5c4 100 times 2 power 4 plus 5c5 2 raised to 5. 5c0 is 1. 100 power 5. 2, 3, 4, 5. 10 zeros will be there. Then next term plus 5c1 is 5, 5 twos are 10, and 100 power 4. 1, 2, 3 and power 4. 5c2 is 10 into 2 square, 4, 40 times 100 cube. And then next term 5c3. 5c3 and 5c2 are same, that is also 10, and 2 cube is 8. So 80 times 100 square. 100 square and 80. Then 5c4 is 5. 5 times 16, which is 80. 80 into 100, which is 8,000. And the last term 5c5 is 1 and 2 power 5 is 32. Let us add these values. It is 2, 3, 0, 8, 0, 8, 0, 4, 0, 1 and 1. This is the answer. Question number 8. Using binomial theorem, we have to find the value of 101 raised to 4. We can write this as 100 plus 1 raised to 4. Let us write the binomial expansion. 4c0 100 raised to 4 plus 4c1 100 cube plus 4c2 100 square plus 4c3 into 100, and the last term is plus 4c4. 4c0 is 1. So 100 power 4. And then 4c1 is 4. 100 cube. Plus 4c2. 4c2 is 4 factorial by 2 factorial into 2 factorial. Cancel 2 factorial. 3 times 4 divided by 2, which is 6. So 6 times 100 square. And then 4c3 is 4. 4 times 100, which is 400. And the last term is 4c4, which is 1. Let us add and write. And this is the answer. Question number 9. 99 raised to 5, which can be written as 100 minus 1 raised to 5. Let us write the binomial expansion. 5c0 100 raised to 5. Alternate positive and negative terms because the middle sign is negative here. Minus 5c1 100 raised to 4 plus 5c2 100 cube minus 5c3 100 square plus 5c4 times 100 minus 5c5. 5c0 is 1 and 100 power 5 is minus, I'll write negative values here, minus 5c1 is 5 times 100 power 4 plus 5c2. 5c2 is 10. 10 times 100 cube. And then 5c3. 5c3 is also 10 and 100 square. plus 5C4 is 5 into 100, which is 500, minus 5C5 is 1. Let us add the positive values. Minus, add the negative values. Let us subtract and write 9, 9, 4, 0, 0, 9, 9, 0, 5, 9. Question number 10. Using binomial theorem, indicate which number is larger. 1.1 whole raised to 10,000 or 1000. Let us write the binomial expansion for 1.1 whole raised to 10,000. We can write 1.1 as 1 plus 0.1 raised to 10,000. Let us use binomial expansion. 10,000 C0 times 1 plus 10,000 C1 times 0.1. Next term is 10,000 C2 0.1 square plus etc. First term is 1 and the second term is 10,000 multiplied with 0.1 is 1000 plus you have positive terms here. Sum of the first two numbers itself is 1001 plus we have positive terms. Therefore, 1.1 whole raised to 10,000 is greater than 1000. Question number 11. Find a plus b whole raised to 4 minus a minus b whole raised to 4. Hence, evaluate root 3 plus root 2 raised to 4 minus root 3 minus root 2 whole raised to 4. Let us write the expansion for both these terms. The first term is 4c0 a raised to 4. Second term plus 4c1 a cube b plus 4c2 a square b square 4c3 a b cube and last term is 4c4 b raised to 4 minus of. This expansion will have alternate positive and negative signs. 4c0 a raised to 4 minus 4c1 a cube b plus 4c2 a square b square minus 4c3 a b cube and plus 4c4 b raised to 4. The first term gets cancelled. These two are getting cancelled and these two are getting cancelled. So we get 2 times 4c1 is 4 a cube b and 4c3. This minus and this minus will become plus. So 2 times 4c3. 4c3 is 4 ab cube. We can take 4ab out. So we get 8ab times a square plus b square. Hence evaluate. Using the result which we got now, we have to find the value of root 3 plus root 2 raised to 4 minus root 3 minus root 2 raised to 4. So we have to substitute a as root 3 and b as root 2 in the final answer. Therefore, it becomes 8 times root 3 times root 2 times a square is 3, b square is 2. Therefore, the answer is 5 8s are 40 root 6. Next question. Find x plus 1 whole raised to 6 plus x minus 1 whole raised to 6. First we will do this. Let us write the expansion. 6c0 x raised to 6 plus 6c1 x raised to 5 plus 6c2 x raised to 4 plus 6c3 x cube plus 6c4 x square plus 6c5 x, and the last term is 6c6 plus the second expansion, alternate positive and negative signs. 6c0 x raised to 6 minus 6c1 x raised to 5 plus 6c2 x raised to 4 minus 6c3 x cube plus 6c4 x square minus 6c5 x and plus 6c6. Cancel positive and negative terms. We have 2 times 6c0 is 1 x raised to 6 plus 6c2, 6 factorial by 2 factorial times 4 factorial. Cancel 4 factorial. 5 times 6 by 2, which is 15. 15 x raised to 4 plus 6c2 and 6c4 are same. This is also 15 x square and 6c6 is 1. Now see the second part of the question. Hence or otherwise evaluate. So using this result, evaluating will be easier. We have to find the value for root 2 plus 1 whole raised to 6 plus root 2 minus 1 whole raised to 6. So we have to substitute x as root 2 in the final answer. So 2 times x is root 2. So root 2 raised to 6 plus 15 times root 2 raised to 4
plus 15 times root 2 square
and plus 1. Let us simplify and write. Root 2 power 6 will be 4 2s are 8 plus root 2 power 4 is 4. 4 times 15 is 60 plus root 2 square is 2. 2 times 15 is 30 and plus 1. And this total is 99. 2 times 99 is 198. 13th question. Show that 9 raised to n plus 1 minus 8n minus 9 is divisible by 64 whenever n is a positive integer. We can do this question by principle of mathematical induction method also. Let us solve this using binomial theorem. I am taking the first term 9 raised to n plus 1 and let us write this 9 as 1 plus 8 whole raised to n plus 1. Now use the binomial expansion. N plus 1 C0 plus n plus 1 C1 times 8 plus n plus 1 C2 8 square plus n plus 1 C3 8 cube, etc. The last term will be n plus 1 C n plus 1 8 raised to n plus 1. So the first term is 1. The second term is n plus 1 C1 is n plus 1 times 8. Now from the rest of the terms, I am going to take 8 square out. So I will have n plus 1 C2 plus n plus 1 C3 8. 8 remains there, plus etc. The last term will be n plus 1 c n plus 1. We have 8 raised to n plus 1. I am removing 8 square. So it becomes 8 raised to n minus 1. This is 8n. 1 plus 8 is 9. Plus 8 squared times n plus 1 c2 plus n plus 1 c3 times 8 plus etc. The last term is n plus 1 c n plus 1, 8 raised to n minus 1. Let us take 8n and 9 to the other side. So the left hand side will have 9 raised to n plus 1 minus 8n minus 9 is equal to 8 squared times n plus 1 c2 plus n plus 1 c3 times 8 plus etc. The last term will be n plus 1 c n plus 1, 8 raised to n minus 1. Here we have 8 square, which is 64. Therefore, I can say that this expression is divisible by 64. Therefore, 9 raised to n plus 1 minus 8n minus 9 is divisible by 64. Question number 14. Prove that sigma r is equal to 0 to n of 3 raised to r times NCR is equal to 4 raised to n. Let us take the left hand side, which is sigma r is equal to 0 to n, 3 raised to r, NCR. Substitute r as 0. 3 raised to 0 is 1, and we get NC0. Next, r is equal to 1. So 3 raised to 1, NC1. Next term will be 3 raised to 2, NC2, etc. Last value of r is n. So 3 raised to n, NCn. And this is the binomial expansion of 1 plus 3 whole raised to n. Therefore, it becomes 4 raised to n, which is the right hand side.